Hey now, welcome to the CI/CD for Containers webinar. My name is Leo Jadnovsky. I'm a Principal Solutions Architect at AWS. And today we're going to talk about CI/CD as it relates to EKS and ECS. And so we'll first cover some foundational stuff as it comes to CI/CD. Then we'll talk about how CI/CD works for modern applications and how we define modern applications. And then we'll dive deeper into continuous integration and continuous deployment, and also how to do CI/CD for when you're doing infrastructure as code. And then lastly, we'll do some demos on with CodePipeline deploying to both ECS and EKS. So let's talk about some foundations here. There are four release stage processes when it comes to taking your code to production. The first one is the source stage. This is where your developers are writing their code, and then when they're done, they check their code into a version control repository for the purposes of this webinar, let's say Git. And so then after they do that, there's a peer review of their code that happens. And so after that's done, it goes to the build stage. In the build stage, this is where your code is compiled into an artifact, if in fact it's a language where that needs to happen. You do your unit tests, you do your style tests, and you create a deployment artifact. So for the purposes of this webinar, the deployment artifact is going to be a container image. But if you're doing, for example, EC2, that deployment artifact could be a zip file that gets deployed onto your instances, or it could be an Amazon machine image or an AMI. If you're doing serverless, it could be a Lambda function. So it just depends on what it is that you're actually deploying and what the underlying infrastructure is. And then we go on to the test stage. So this is where you do integration tests with other systems. You're doing your load testing here, your UI testing, and your security testing. And for security testing, I think it's really important to do as much of your security testing before you get to production instead of after the fact. And then lastly, we have production. So this is where you deploy to your production environment or environments. And also, after your code's deployed to production, this is where you're monitoring it to quickly detect errors or regressions. So if there's some kind of problem, you could roll back or roll forward quickly. So let's talk about how CI/CD plays into this. Continuous integration really covers the source and build stages. So when you're doing continuous integration, that means that anytime there's a check-in to the mainline branch of your version control repository, that kicks off a build. The build either results in a artifact that is ready for deployment, or it results in some kind of failure of a test, and the build errors out, and you have a quick feedback loop for your developer to be able to fix whatever went wrong, so they can do another build and have an artifact ready to deploy. And then we've got continuous delivery. So continuous delivery is when you have full automation that takes your code from source to build, to test, to production, but you've got a manual gate before you go to production. So somebody has to go in and approve to make sure that the changes that are about to be deployed to production are in fact what you want to go into production. And then lastly, we've got continuous deployment. So continuous deployment is when you have full automation from source to build to test to production, and there's no manual gates. So most of my customers I talk to, they're really, when they're trying to implement CI/CD, they really want to get to continuous delivery. So they're trying to have full automation, but they still want to have the safety of having a manual gate. But as they get there, they increase their operational excellence and automation and setting this up. And so they might decide, okay, we're going to, for some services that are part of our application, we are going to do continuous deployment because they're low risk. Or some other customers might decide we're going to do continuous deployment for everything. And other customers might decide we're going to not do continuous deployment for anything. We're going to have continuous delivery. We're going to have a manual gate. And there's no right or wrong answer here. What you do really depends on your appetite for risk, your compliance situation, and other factors. It just depends on what your application actually is. So now let's take a look at different AWS code services. So these are the services that we have for each of these um, processes. So for the source stage, we have a service called AWS Code Commit. And so Code Commit is a managed Git service. Then we've got CodeBuild. So CodeBuild allows you to build artifacts. In the demo a little bit later on, we'll be using CodeBuild to build our Docker container images. You could also do tests with it, things such as unit tests as well. And then for testing, again, you can use CodeBuild for some of it. For things like integration tests and UI tests, you probably want to use some kind of third-party open source tools for that. And for deployment, we've got a service called CodeDeploy, which we'll dive deeper on in a little bit. But CodeDeploy allows you to deploy your code to EC2, to ECS, to Lambda, as well as to on-premise resources as well. And then for monitoring your code and doing tracing, we have X-Ray, which allows you to do distributed tracing, and we have CloudWatch, which gives you metrics on your what you have running in AWS, and also centralized logging and insights into those logs. So then we've got CodePipeline, and CodePipeline orchestrates the movement of your artifacts or applications between all these phases. So CodePipeline can take your code and basically watch when there's a new commit on a certain branch in CodeCommit or GitHub or other sources, and then trigger a new pipeline run. It can then do tests and builds and CodeBuild. It can trigger third-party tools as well. It can trigger deployments, and so it'll see your deploy through from beginning to end. And then we've got CodeStar. And so CodeStar is a service that allows you to quickly get started with some combination of these services. So you can go into CodeStar, you can quickly pick a template, and then within a few minutes you'll be up and running with some combo of these services. And so it's a really good way to get your feet wet with the AWS Code Suite. So let's move on to talking about modern applications and what is a modern application. So a modern application means that you can, if you're doing modern application development, that means that you can accelerate the delivery of new high-quality services. You can have really simple environment management with them. You can reduce the impact of code changes, meaning a deploy shouldn't be a big deal. You should be doing a lot of deploys multiple times a day. You can automate your operations, which means nobody should be going in and manually SSHing or running commands on instances or servers. And you should be able to gain insight across your resources and applications to see how your applications are performing and basically pick up on errors before your customers see them. And you should be able to protect your customers and business, both from a security and a compliance point of view. So CI/CD allows you to accelerate the delivery of new high-quality services. Serverless and microservice architectures allow you to both simplify your environment management and reduce the impact of code changes. And modeling your applications and infrastructure as code allows you to automate the operations of your applications. And you can gain insight across your applications and resources by enabling observability. And to protect your customers and business, you need end-to-end security and compliance. So let's dive into some of these. First, let's talk about CI/CD. So why is CI/CD important? CI/CD means that, according to the State of the DevOps report, those teams that implement CI/CD, that means that they can reduce their deployment frequency, so the frequency that they deploy their code, from weekly to monthly to hourly to daily. They can reduce their lead time, so the time that it takes for code to get from being code to being in production, from 1 to 6 months to 1 to 7 days. And they can reduce their change failure rate, so basically a bad deploy or introducing some kind of problem into production, from 46 to 60% of the time to 0 to 15% of the time. And so according to the State of DevOps report from 2018, 48% of software teams that implemented CI/CD were able to realize these results, like the change in failure rate. So this is something that's real, that adds real value to you. So let's talk again about continuous integration. So what is continuous integration actually? Continuous integration means that you automatically kick off a new release when new code is checked in to the mainline branch of a repository. So you've got a Git repo, you've got your code in the mainline branch. Whenever there's a new commit into that mainline branch, that should kick off a build. And that the build should be run, and you should run tests on it. And this should be done in a consistent, repeatable environment. So the build and tests are actually indicative of whether your code is going to work in production, and the build and tests have the same environment every single time. So this allows you to have an artifact for feedback at all times. So once your CI/CD process is set up, if a build and the test cycle is successful, you'll have an artifact ready for deployment. And if you don't have an artifact ready for deployment, if there's a failure, you'll have a feedback loop. So you should see exactly why it failed, what you need to do to fix it, and as soon as you put a fix in place and check it back into the code repo, that'll trigger another CI/CD cycle, and if that worked, you'll have an artifact ready for deployment. So we have a service called AWS CodePipeline that you can use to help you with this. CodePipeline is a continuous delivery service which allows you to do fast and reliable application updates. It also allows you to model and visualize your software release process, and it can run a set of builds, tests, deploys every time there's a code change. These builds, tests, deploys can happen with both AWS services such as CodeBuild, CodePipeline, or CodeDeploy, Elastic Beanstalk, and so on. And you can also integrate third-party tools, so things like Jenkins and managed load tests with BlazeMeter, and any kind of custom test as well. You can do a custom Lambda action that triggers basically anything you configure the Lambda function to do. So let's talk about supported sources for CodePipeline. CodePipeline allows you to trigger your pipelines with Git, so that's either with code commit or GitHub. So you can pick a code commit repo or GitHub repo and select a branch, and anytime there's a commit to that branch, that'll trigger the pipeline. You can also trigger it off of S3. So you can have an object in S3 and monitor that object, and when the new version of that object gets triggered, that'll trigger a pipeline. So if you've got something like GitLab or just a Git repo running on an instance, you can basically configure a hook on those Git repos to trigger taking the commit and putting it in S3 and having that trigger pipeline. Another great thing, especially for containers, is that you can now use the Elastic Container Registry or Amazon ECR as a pipeline source. So you can have a pipeline that builds your Docker container image, and then you can monitor for a new container image in your ECR repo with a specific tag and have that trigger your pipeline. So you can have a pipeline that builds the container image, and you can have another pipeline that then uses that container image as a source and triggers deploying that image into your ECS or EKS cluster. So let's talk about supported deployment targets. You can have CodePipeline deployed to CodeDeploy and anything that CodeDeploy supports, such as EC2 instances, on-premise servers. You can have it deployed to Elastic Beanstalk and to OpsWorks stacks. In terms of containers, you can use the container deployment functionality in AWS CodeDeploy, and then you can deploy from CodePipeline to ECS, either through a regular ECS deploy, a blue-green deploy, or to an ECS Fargate cluster. And for serverless, you can deploy to Lambda using CodeDeploy, using a serverless application model or SAM, which is an extension of CloudFormation, or directly to Lambda. So it's up to you. So you have multiple ways to deploy. So let's talk a little bit about the ECR source action. So you can have a pipeline, and again, the source of that pipeline could either be the master branch of your repo, or it can be your ECR repository with a certain tag, and that can then go and deploy your container image. And I'll show you how this works basically in the demo coming up. So CodePipeline also supports triggers. So instead of just deploying whenever there's a new deploy to your code repo or to your ECR repo, you can also kick off a release on a schedule. So for example, if you want to do a nightly release, you can do that, and that's powered through CloudWatch events. And you can also do it through health events. So again, Fargate is a managed service, right? So it's serverless. You don't have to manage the underlying ECS cluster. So when things happen, like your Fargate platform gets retired because there's a new version of it, you can have that automatically trigger a deploy to the replacement updated platform. And so that's available in both the CloudWatch Events console, our APIs, SDKs, CLI, and CloudFormation. And you can also go off of webhooks. So you can have a webhook trigger CodePipeline from places such as Docker Hub, Quay, and Artifactory. So let's talk about deploying to ECS and EKS clusters. So first of all, when it comes to serverless, we've got two services for that, at least for serverless compute. So the first is AWS Lambda, and Lambda is a serverless function service. So Lambda allows you to execute a function. There's many built-in language runtimes, so like Python and Node.js, and you can also bring your own runtime. So if it's a runtime that we don't provide for you, you can make your own runtime with whatever language you want. It's event-driven, so you can trigger your Lambda functions off of a schedule, off of something dropping in an S3 bucket, off of API gateway traffic, all kinds of things there, and you only pay for what you use, and there's no server management. The function gets triggered by an event that you define, and when the function stops running, you stop being built for it. And there's a lot of data source integrations. So for example, you can have a Kinesis stream trigger Lambda functions. You can have DynamoDB trigger Lambda functions. All kinds of neat functionality like that. So for longer running tasks, though, that's where you want to go to AWS Fargate. So Fargate is a serverless container service. It abstracts the operating system away from you, and it fully manages both orchestration and cluster scaling for you. So if you want to launch, for example, a normal ECS cluster, you have to launch EC2 instances, and you have to run the ECS agent on them, and you have to manage the auto-scaling of those instances. When you're running Fargate, you don't have to do any of that. The instances that run Docker are automatically managed for you. So let's talk about CodeBuild and how that comes into play when it comes to containers. CodeBuild is a fully managed build service, and it compiles your source code, runs tests, and produces software packages for you. It can scale continuously, and it can process multiple builds concurrently. So in CodeBuild, you set up a project, and you set up what Docker container image you want that project to be built in, and that can be one of our container images that we give you with a build environment in it, or you can bring your own build environment. There's no build servers to manage. It's paid only for what you use. So when your project is triggered, that spins up a Docker container that runs your build environment, and when that build is done, you stop being built for it. So you don't have to have permanently running build servers. And you can monitor what's going on through CloudWatch and CloudWatch events. So you'll see my demo, you can see the output of the build live through both the web console and also just you can get that data through CloudWatch logs as well. And so the way that CodeBuild works is each build runs in a Docker container for a consistent immutable environment. So every time there's a build, there's a fresh Docker container, so their environments don't get reused. The Docker and AWS CLI are pre-installed in every official CodeBuild image. So if you need to run a command like copy a file to an S3 bucket, or trigger something happening with your ECS cluster, for example, those are all built into the official CodeBuild images, and you can also build those in to any custom CodeBuild images that you use. And so you can provide custom build environments as well, again, through the use of a Docker image. So let's take a look at what a CodeBuild project looks like for both building a Docker container and for deploying with EKS. So this is a build spec.yaml file. And so in this case, what we're doing here is we are logging into our ECR repository. We're building a Docker container. we're tagging that Docker container and we're pushing it to the repository. So if I had this as my build spec file, my CodeBuild project would create a Docker container and push it to the ECR repo. And you'll notice here that the first command is AWS ECR get login. And so your Docker or your CodeBuild project runs with an IAM role. So if you give that IAM role the permissions to log into your ECR repository, for example, you don't need to have any AWS credentials in here. It'll just use the credentials that it gets from the role, which is really good from a security perspective. Now, what about if we want to deploy with EKS and build a container with EKS? So as of right now, EKS isn't a supported target from CodePipeline natively. So what you can do is you can handle the deploy in CodeBuild. So in this example, this is a build spec.yaml file. And what we're doing here is we're downloading the IAM Authenticator and kubectl utilities, which allow us to talk to our EKS cluster. We're then going to, again, log into the ECR repo, build our Docker container, and push that Docker container up to the repo, and then update our service in EKS to use that new container image that we just built. So I'll show you how this works in the demo as well. So that's continuous integration. Let's talk about continuous deployment now. So again, continuous deployment, what that basically allows you to do is you can deploy new changes to a staging environment for testing. You can then have a manual gate. And so once somebody goes in and looks at the staging environment and declares that it's okay, you can then deploy to production safely without causing downtime or any kind of negative impact for your customers. And you can then deliver your code to your customers faster, increase deployment frequency, and change or reduce lead time and change failure rate. So those are all good things. And a service that we have that allows you to do that is CodeDeploy. So AWS CodeDeploy handles deployments to any instance and Lambda, as well as ECS. It can handle the complexity of updating your applications, meaning that let's say your application is behind a load balancer, so an ALB or an ELB. It can take your instances out of the load balancer, so you won't be serving traffic to instances where there's a deployment going on. It can health check your deployment to make sure that your application is healthy after a deployment before putting it back in production. And so this allows you to avoid downtime during your application deployments. It also supports rollbacks. So if any kind of failure is detected, you can roll back and then do a new deployment once your application is healthy. And CodeDeploy supports deploying to EC2, ECS, Lambda, as well as on-premise servers as well. So just like CodeBuild is configured with a buildspec.yaml file, CodeDeploy is configured with an appspec.yaml file. So this is an example of an appspec.yaml. And so in this example, this is for EC2, not containers. So in this example, we are copying files to the var www.html directory. We're setting some permissions on those files, and then we're running a series of shell scripts to handle the actual deployment. So the nice thing here is it doesn't have to be shell scripts. It could be a Puppet manifest or Ansible or Chef. However it is that you want to handle the actual automation of your deployment, it supports that. Another thing that CodeDeploy supports is the ability to choose the deployment speed and group. So you can deploy to one instance at a time, half at a time, all at a time, or a custom deployment speed. And you can also deploy based on tags or based on auto-scaling groups. So when it comes to deploying from CodeDeploy to ECS, CodeDeploy now supports blue-green deployments to Fargate and to ECS. So let's take a look at how that works. So when you're doing a blue-green deployment in ECS, that means that you have a set of tasks that already are running your code. So we'll call those tasks the blue tasks. And when you do a new deployment, it's going to provision a new set of tasks called the green tasks, and then it flips traffic to those tasks from the load balancer. Now, at each stage of the deployment, you have validation hooks to make sure that your deployment's healthy, that your new version of your application is returning what is expected. And so these hooks are done through Lambda functions. And so basically, if there's any kind of problem detected, the traffic is rolled back from the green tasks back to the blue tasks, and this takes seconds. You can monitor the deployment status and history through the web console, APIs, SNS notifications, or CloudWatch events. And if you want to set this up in CodePipeline, you should use the CodeDeploy-ECS deploy action, or if you're doing this in Jenkins, you can just use the AWS CLI to do it. Let's take a look at an app spec file for ECS. So if we're deploying to ECS, here we're defining the service, what it looks like in ECS, what the task definition we want to use, and the load balancer we want that service to be attached to. And then we define our lifecycle hooks. And so these hooks are our Lambda functions. So we'd have to write little Lambda functions to basically check our application at each of these lifecycle hook stages. So let's take a look at how this works. So we've got an application load balancer, and then that has a production traffic listener attached to it, and it's listening on port 80. And that has a target group attached to it. So right now, before we do the deployment, all of our traffic is going to our original code, which are our blue tasks. And these tasks are running in Fargate. When we do a deploy, it's going to spin up a new traffic listener on a different port and a new target group that's attached to this new traffic listener. And it's going to spin up a set of new tasks. So the new green tasks are going to have the new version of your code. And as soon as that is finished, we're going to run one of these hooks that's a Lambda function against the test endpoint to make sure that the green tasks are acting as expected. So if that is in fact the case, then the production traffic listener that's on port 80, then it flips over to the new target group with the new tasks on it. And if something fails at that point, you can also roll back to the original target group. And then you drain the blue tasks. So as traffic basically drains from the original tasks, you terminate those tasks. So let's talk about some also best practices for container image tagging for deployments. So Docker tags are resolved when a container starts, not just during the deployment. So this means that if you specify in your task definition the latest or prod, what that means is that you can have untested code that goes into production if you have a scaling event. So what you want to do instead is use immutable image tags for deployment. So let's take a look at what this actually means. So we've got our tasks running on Fargate, and they're running off of the latest tag. And we've got that tag is based on a container image that's in ECR. So we have a new build that goes on, and the build succeeds, but it hasn't done any of the deployments to staging or production yet, but it does push a new container image to ECR, and it tags it the latest. So now we've got our new image that's tagged as the latest. And the service scales up, you've got more traffic, so there's a scale-up event, and starts launching new tasks. So if your service definition is based off of latest, it's going to automatically launch off that new container image that may have not gotten through all the testing in your full CI/CD pipeline, and so you might have undesirable results then. So what you want to do is you want to deploy using immutable tags. And two options for that are the SHA-256 digest of the container image, or the build ID that you get in CodeBuild. And so you get either of those. The SHA-256 digest you can get from a Docker inspect command, as shown here, and the build ID you can get off of an environment variable that's automatically set in your CodeBuild environment called CodeBuild build ID. So what you want to do is use a specific build ID. That way you'll get deployments to production based on specifically which deployment you want. So you got a new build, that new image is tagged with a new build ID. And so when your service scales up, it's set not to latest, but to a specific build ID. So until that new build ID gets promoted to production, it's still going to launch images with your old build ID. And So now let's take a look at infrastructure as code. So again, we can automate our operations by modeling applications and using infrastructure as code. And so infrastructure as code means that you can make infrastructure changes repeatable and predictable. It means that you're treating your infrastructure just like you do with your application code. So you use the same tools to do code changes for your infrastructure as you do to do code changes to your application. And you can easily replicate a production environment in a staging environment to enable continuous testing because your environments are just pieces of code that you can spin up on demand. So to do that, what you want to do is use CloudFormation. So CloudFormation allows you to define an environment in a CloudFormation template. And then you can use CodePipeline to actually deploy that CloudFormation template. So you store your CloudFormation template in a Git repo. You have a code pipeline for your CloudFormation template. And so when you can have the source code in something like code commit, then when you make a change to your CloudFormation template, that kicks off a build of the pipeline, and you can then have a code build stage. In the code build stage, you could do something like run CFN lint or CFN nag, which are two utilities to basically test your CloudFormation template. You can then do a test stage where you do a change set, and then if that all goes well, you can deploy your CloudFormation template in the production stage. And so it'll do a change set to create a new CloudFormation stack, or if it already exists, it'll update the existing CloudFormation stack. So another thing that you can do is our new CDK, or AWS Cloud Development Kit. So CDK allows you to define cloud infrastructure in TypeScript, and it provides you a library of higher level resource types that have AWS best practices already built in, and they're packaged as NPM modules. So you can provision, it provisions resources ultimately as CloudFormation, but when your developers use CDK, they can use far less lines of code than a traditional CloudFormation template. It also supports all CloudFormation resource types. So let's take a look at what a CDK template looks like. So in this example, we are defining a VPC. So normally when we define a VPC, we have to think about things like subnets, security groups, internet gateways, NAT gateways, NAT calls, route tables. So in this example, we're just using the built-in higher level class. And so this one line of code will define all that stuff for you according to AWS best practices. We then define an ECS cluster. So that's the second line there. And so we're defining a cluster that lives in that VPC we just defined. And then we're setting up a Fargate class that defines the ECS service, the task definition, the application load balancer, that it's tied to the listener rule, the target group, and optionally their Route 53 record. So normally this would take about 400 lines of CloudFormation syntax. We've got it down to 22 lines of TypeScript code. And so you can model your pipelines with AWS CDK. So what that means is you can define what is a best practice code pipeline for my organization or for the specific application, and you can define what that pipeline shape looks like in one class and then reuse it across many pipelines. And again, CDK includes a lot of high-level constructs for modeling a code pipeline, but you can also build your own if you don't like the ones that are built in. And so what that looks like, here's an example of a pipeline, a CDK pipeline construct. So here we are defining a pipeline with a GitHub repo as a source. And if we want to instantiate 4 of these pipelines, it's just 4 lines of code. And this will spin up 4 code pipelines in CloudFormation templates. So again, it's much quicker than manually spinning up 4 CloudFormation templates or creating these templates over and over again. So to control the CDK, there's a CDK CLI. So this is generally how you use it. And in CodePipeline, you can use CloudFormation deployment actions with any synthesized CDK application. And in Jenkins, you can just use this cd CLI and install that on your Jenkins instance. So that's infrastructure as code. So now let's go to a demo. So for today's demo, we're going to do two things. So we have two services here. We have this service is running on an EKS cluster, and so it's just going to say hello world and give me my environment variables and display a Fibonacci sequence. And then the second service, this is running on ECS. So this is an Nginx web server running on a service that's running on ECS. So let's take a look at how this looks like. So first of all, we've got our code pipeline, and we've got one pipeline for each. So let's go through EKS first. So for EKS, we've got our code and code commit, and that triggers a project in CodeBuild here. So here is the build spec file. So again, what this does is this handles both building the Docker container image and also deploying that image to my EKS cluster. So it's going to download my IAM authenticator and kubectl. It's going to do some apt-get updates. We're going to log into my ECR repo. We are going to build the container, push it to the ECR repo, and then update my EKS service to then to use the new container. So let's actually go ahead and trigger a change here. So I'm going to go to my EKS folder, and what I need to do is I'm going to change the main.go, which is the actual application and code here. I'm just going to change my hello world greeting. So instead of 3 exclamation marks, I'm going to do 1 exclamation mark. So I've changed it right here. And so let me go and actually commit that change to Git. So we're going to do a git status. Yep, so I've changed my main.go file. So I'm going to commit that. All right, and we're going to push that. And so doing this push is going to trigger my code pipeline. And so while that's triggering, let's take a look at what's going on here. So that's going to execute this code or this build spec.yaml. So let's take a look and see if it's picked that up yet. It has. So my pipeline is already running. And what it's doing right now is it's taking this commit that I just did, and it's packaging it up into a zip file, and then it's telling CodeBuild to build that project with my zip file. So CodeBuild is now going. So let's take a look at what's going on here. So this is my project, and it's spinning up the Docker container that it's going to use right now. But in just a minute here, we're going to start seeing output from the actual build. And at the end of the day, what we should see is when we go to my service, it should change 3 exclamation marks to 1 exclamation mark here. So while that's going, here we go. So it's going, and this will take a few minutes, but it's basically executing all those commands in my build spec.yaml. So let's let that run for a minute and go to my other project, the ECS project. So for my ECS project, I've got an ECS cluster here. And so this is my cluster, and it's running, again, it's Fargate, so I'm not actually managing my EC2 instances that the service is running on. And I've got my Nginx hello service here, and it's running on I have two different tasks running across 2 AZs. And so this is my service. We can see the tasks here. They're running. We can see the task definition. It's Nginx hello.4. So let me go here and actually trigger a deployment. So I'm going to go to my other folder here. I'm going to go to my ECS CodePipeline folder. All right, and let's take a look at some stuff here. So first of all, we've got my build spec. Again, this one's a little bit simpler because it's just basically logging into my repo. It's building the container, and it's pushing the container, and it's writing the service definition file here. And notice here that for the image tag, again, I'm using it with a specific commit hash. So that way, again, I can deploy per best practices. So my service deploys a specific commit and not the latest tag. So then we've got my actual code. So again, this is just an index.html file that's served by Nginx. And so I'm going to change my text here from hello world, again, 3 exclamation marks to 1 exclamation mark. And so I'm going to do the same thing here. I'm going to do a git commit. I'm going to push that out to Git, and that should trigger my other pipeline. So let's take a look here. So again, this is still going here. This is back to my EKS one, so we'll give that a few minutes. Let's take a look at what's going on with ECS. So I'm going to go to my other pipeline here, and so here's my ECS pipeline. And so again, it's picked up already that I've made a change, and in a minute or so, it'll trigger my CodeBuild project, and then that'll package up my container into my ECR repo, and that'll trigger my deploy in ECS. So that's going right now, so let's take a look here. So I'm going to tail my log here. And so it's already, as you can see, it's going through the build, and this should actually be pretty quick. And it's succeeded. So it's built my container, it's pushed it back up to the repo, and it's created a new task definition. So now my code pipeline will pick up that's done in about a minute here, and it's going to go to ECS, and we're going to do an ECS deployment. So while we're waiting for that, my original pipeline should be pretty much done by now. So let's go to my EKS pipeline. And yep, it succeeded. So let's go to the EKS service just to make sure that it's actually gotten deployed. So yep, so we went from 3 exclamation marks to 1 exclamation mark. So my EKS deployment is successful. All right, so let's go back to ECS now. So I'm going to go to my ECS pipeline, and we can see the deployment is in progress in ECS. And so we can see the deployment here. And so now we were at Nginx Hello 5, and now we're at Nginx Hello 4. So it's updated the task definition. And let's take a look at that task definition here. So we can see here, this is the image that it's using. So again, this is the git commit hash of my new commit. So if we go here, you can see it's C440E8CC. So that is the same. That's here. So it's not, if there's an auto scaling event or something, it's not gonna deploy my new code until I mean to deploy it. So let's go here, and again, this is gonna take a few minutes because it has to drain the traffic from the old service. But if we go here, if we go to my service, we can see it's in the process of deploying. But let's see what happens. I'm gonna go and we can see actually what's active and what's primary. So this is the old version of my service, and this is the new version of my service. So let's take a look here, and it looks like one of my, so as you can see, it's hitting, this is my load balancer, and it's hitting different containers. So when the traffic finishes draining, I won't see 3 exclamation marks anymore. But for now, since it's in the process of draining, I'm getting some. Every time it refreshes, I'm getting sometimes my old container, sometimes my new container. So that's a deployment pipeline for both ECS and for EKS as well. If you would like to learn more about both CI/CD as it comes to ECS or EKS, go ahead and take a look at these resources. So we've got ecsworkshop.com and eksworkshop.com. And then on the eksworkshop.com website, there's a specific section actually for setting up CodePipeline and CI/CD to do the deployments. And for ECS, take a look at this ECS CodePipeline reference architecture, and that'll help you set up a similar code pipeline to the one I had in the demo. So that's what I had for you today. Thank you so much for your time, and thank you for coming. And now we're gonna go to Q&A.